I will now be talking about the development of the sanitation device that I have decided to build. For my filter that I'm going to build, the materials that you will need are 2 bottles, something such as a knife or scissors to poke holes with, and in order of layers, cotton balls, crushed charcoal, sand, small rocks, and a membrane filter. Method: collect 2 empty water or Coke bottles and cut off the tops as for room to place filter material or filtering bottle. Poke holes in the bottom of only one of these bottles. In the bottle with the holes, place cotton balls, then charcoal, sand, small rocks, and finally a membrane filter on the top fixed with an elastic. Place the bottle with the filtering material over the empty clean bottle. Then collect the water you wish to filter and pour that water into the bottle which has the filtering material. Wait until the water has gone through into the clean bottle, producing clean water. I hope my filter will rid of any harmful bacteria and viruses, algae, and any grit or dirt. To test this, you can buy a home water testing kit for around $15 off Amazon, which tests for substances such as nuisance bacteria, disease-causing bacteria, the most common are E. coli and chloroform, but also include fecal chloroform and fecal streptococcus, among others. It also tests for metals such as iron, manganese, and lead. You can also test for fungus and bacteria by inoculating agar in a petri dish with your water. Although, with my filter, we do not do this process. To make sure your water is pure and drinkable, you should always boil your water before drinking it if possible. Trial 1. Although my filtered water came out clean and clear, one issue found was that some of the cotton from the cotton balls had escaped through a hole and ended up in the water. Although this is not a large-scale problem, as the water is still mostly clean, I fixed this by putting another membrane filter on the bottom of the filter to catch any materials that may slip through. I measured that only 200 ml of the filtered water output resulted from the original 400 ml of input. I hypothesized that as the unused sand was originally unsaturated, for this initial trial it became saturated by absorbing the water being filtered. This resulted in only 50% of the filtered water being the output. I hypothesized that in the second trial, given that the sand is already saturated, a greater quantity of filtered water will flow through, resulting in greater output. There were 2 difficulties I faced during the construction of my filter. One was placing holes in the bottom of the water bottle. This was very difficult, and in the end I had to get my dad to get nails and a hammer to punch holes through. Also, the crushing of the charcoal took a lot longer than I expected. Materials, cost, and availability. Bottles, I used $0 worth as it was a recycled bottle. Recycled bottles should be available anywhere in the world, as companies like Coke are available in first world and third world countries. I used about 5 cents worth of cotton balls, and these are also widely available, although if not, this can be replaced by other cotton materials such as clothes. Charcoal, I used $0 worth, as this is available everywhere in the world, as you just need wood to burn. Sand, I used around 50 cents worth. This is also widely available, as well as small rocks, which I used $0 worth. Membrane filters, 5 cents worth. Most areas these are available in, although if not, in third world countries, these can also be replaced with any type of clothing or cloth. My hypothesis was proven true, as, in my modified version, had an output of 375 ml out of the 400 ml due to the sand being pre-saturated. References from lifehacker.com, afraid of contamination and how to test water in your house, WikiHow, Sydney Water, and appslab.com.